There we go. Okay. All right. So the ratio of concentrate to water for most juices is 1 to 4. Okay. How much water and how much concentrate are needed to make 3 liters of juice? Okay. That's the question here. So what we want to do, we're going to have like, first off, I would write out the ratio here. Okay. 1 to 4. Okay. Now it uses the terminology like parts, right? Almost like how many parts are in this mixture? Like when you actually have a final product here of like a thing of juice, how many parts are going to be in that in total? Kenneth? So okay, there's 2 things, but there's going to be like 1 part concentrate and 4 parts water. So how many parts in total, I suppose? 5. Okay, so there'd be five things in total, right? 5 like times you're gonna pour something into this bucket. So that's the other catch here is you're gonna have like a ratio of 1 to 4 to 5, where 1 is gonna be like the concentrate, 4 is gonna be the water, and 5 is gonna be the total. Okay, there's a few different ways to tackle a question like this. What I found is if you look at like, you break this into 2 pieces. If I look at this piece here, like one like concentrate to the total, then I could go 1 divided by 5. Do we happen to know what 1 divided by 5 is off the top of our head? If you don't, then you could think of it as like a equivalent fraction, if you will. What's another fraction that's equivalent to 1 over 5? Allie? 2 over 10. Is that helpful for anybody? If you got 2 out of 10 questions on a test, right, what would be your percentage or your decimal? Just out of curiosity. Do we know how to do this? Yeah? Well, it's 0.2, right? So anytime you're dividing by like, if you had 2 and you divided it by 10, 2.0. You guys do this in science? I'm not sure. If you do this and you divide by 10, you would take the decimal spot and move it 1 to the left. Okay, if you don't know that, I'll do it for you. We'll do maybe a whole sheet of this in here, okay? This is like a quick way to like convert things and figure stuff out, okay? So anyway, it's known to me because I've been around the block a little bit, right? That 1 divided by 5 is 0.2, okay? Which means 20% of this final mixture is going to be concentrate. Does that make sense? So if you looked about, if you wanted to convert something into percentage, right, you would multiply by 100. That would be 20%, right? Okay, you don't need to write that down. I'm just like showing you how that works out. Okay, so 20% of this mixture is going to be concentrate. Okay, and the nice way about doing this is it doesn't matter how much of a mixture you want to make, right? That you just know that in order to attain this, like whatever it is, if it's like lemon juice or like lemonade or something like that, in order to maintain that like how much lemony kind of flavor there is, you know that this concentrate has to be in 20% of the total volume, okay? So that's what's nice about going this road is we know 20% or 0.2 here of the total, right? So to figure out how much or like in volume in liters, what the volume of concentrate is in this mixture, we would take this 0.2 and multiply it by the 3 liters of juice, because we know it has to be 20%. 20% of what? 3 liters, 5 liters, 10 liters, however much you're actually trying to make. Does that make sense? So we do that, we just multiply by 3. 0.2 times 3 should be, if I'm not mistaken, 0.6. Okay, and that's going to be your concentrate, right? So like your sugar packet or something like that, right? Okay, and then we do the same work, except the rest of it, I guess you could do it, I'll do it 2 ways. Because there's only 2 things being mixed here, it's easy enough to figure out how much water you need. You could do it one of 2 ways, and then we'll like prove it using the exact same method, okay? So like using just sheer like intuition, if there's 3 liters in total, and I know there's only 2 things being mixed together, so if I know that 3 liters in total and 0.6 of it has to be concentrate, I can quite easily figure out what water is, right? It would be the 3 liters take away the 0.6 liters. Those look like C's, sorry. Okay, would equal 2.4 liters in water. Okay. Now that's just using intuition, but what if I wanted to like make sure that was 100% right? Well, we could use this exact same process that I just did here. Again, just instead of using the concentrate ratio this time, I'll use the water, right? So I know the amount of water. There has to be 4 parts water to like every 5 parts based on how this is set up, right? So I can do this. 4 over 5. Does anybody know what 4 over 5 is as a decimal? Yes, Kenneth? 0.8. Same thing. You could create an equivalent ratio or equivalent fraction. You multiply both of them by 2, you'd get 8 over 10. If you got 8 out of 10 questions right on a test, it'd be 80%. Right, it's 0.8. Right, so you're going to get 0.8, and you can take that 0.8 and multiply by the total, right? 3 liters. What's 0.8 times 3? If you had to take a guess. Allie? 2.4. Is it like you can use your calculator for this, right? If you needed to check, but you could confirm that using 2 different approaches. Okay, one being kind of intuition after you have one answer, and then the other one being, okay, well, I'll just apply the same process and see if I get the same answer. So it turns out 0.8 times 3 is going to equal 2.4. Okay, that means you need, I think we should write a therefore statement. Therefore, 0.6 liters of concentrate and 2.4 liters of water is needed. Okay, does anybody have any questions there? Again, the one, when you have 2 parts, it's not so bad. But the next question, it gets a little messier. But you can use the same process I just showed you. I think that's probably like, that's the way my mind works. I like this process. You look at what each of the components are relative to the whole thing and find the percentages, and then you could figure it out from there. There are multiple ways to do this. Okay. Okay, we'll let everybody get caught up, and then we'll go to the next one. Okay, and I think like what helps sometimes is if you write out like the ratio right from the very beginning, right? You're very, very clear in what's what too. So on top of it, write down like C for concentrate, W for water, T for total, right? And just be specific in it, okay? And we'll see in the next question, we're gonna have 3 parts now that make up a mixture, okay? And I think if you write the letters on top of the ratio, it just keeps everything nice and organized for you, okay? All right. Okay. Still see some people right. I don't know if we're doing questions ahead or what. All right. So a potting soil mixture contains 4 parts loam, 3 parts peat moss, and 1 part sand. Okay. If 10 parts of loam are to be used, how many pails of peat moss and sand are needed? Okay. So we got 3 things going on here. Okay. We're going to have 4 parts loam to 3 parts moss to 1 part sand. Okay? Maybe I'll use a different approach for this one. Okay? One of 2 ways. Okay? Let's, we'll keep it consistent here. We'll make sure that we write, okay, here's what we got. We've got loam, peat moss, and sand. Okay? Now you could do exactly what I just did in the last question. And we could say, okay, what's the total? How many parts are there in total there? When I have my final mixture, yeah, okay, Colson, yeah. There'd be 8 parts, right? You'd have the 4 parts of loam, 3 parts of peat moss, and 1 part sand. Okay, for a total of 8. Now you could do each of one of these, like, half this mixture is 4 to 8. 4 out of 8 is going to be loam, right? You could do all of this process the exact same way that I just showed you, or when they give you something that's not the total, that's maybe the difference between these two questions. It hasn't told, like, it gave you a stipulation that in the new mixture or whatever we're doing, or we just need 10 parts of loam here, right? I'm going to try and keep it consistent. We're going to have 10 parts loam, okay? And then we have to figure out the other two, okay? Yes, Vincent?
Could you just do 2.5 times?
Yeah, that's what I'm gonna do right now. Yeah. So sometimes, Vincent, that's like the easier way, and like sometimes my mind just like if it tells me a total, like in the last question, it's not as easy to jump there. I don't think, but it could very well be, I suppose, depending on how you set up your ratios and how organized you are. I think, right? So why Vincent's saying 2.5 is, how do I get? This is your question. How do I get from 4 to 10? Yes?
Well, 10 divided by 4 is
Okay.
2.5.
So in order to figure out, this is like it's like a scale factor almost, right? How do I get from 4 to 10? Well, if I figured out that 10 divided by 4 is equal to 2.5, right? Then I could take 4, multiply it by 2.5, and I'd be good. But remember, we're bound by the constraints of what this mixture has, like it has to stay consistent, proportionally speaking, right? And so if I multiply the 4 by 2.5 to get the amount of peat moss in new mixture, I would take the 3 and multiply it by 2.5. Okay, and so I know that in the new mixture, 3 times 2.5 is 7.5. Okay, so I have 7.5 parts of peat moss. And then I can do the same thing with the sand, right? Sand in the new mixture is going to be the 1 times 2.5. It's going to be 2.5. Okay, so now you know. Okay, we could say, therefore, the new mixture ten parts, obviously, of loam. 7.5 parts peat moss, and 2.5 parts of sand. Okay. Okay. Any questions? Comments, concerns? Okay, if I try to relate myself, like I'm just having a hard time looking at the way we did this question and thinking about how to do it in the same way here. Okay? It's me being just struggling. Okay? I'm sure if I sat down to try and figure it out, I could probably figure it out, but I'm having a hard time figuring this out, this process, for the last question. Okay? Do we have any questions? I'll go to the next one. Okay, maybe do one more and I'll let you guys finish off the thing, and we could take up the other ones too. Okay? Okay. So here we go. We've got, let's write a ratio up. 4 to 6 to 5. That's going to be on top. You can make it specific. You can go sand to gravel to cement. Okay. Now, in total, okay, well, I think we could assume that when they're mixing this, we could kind of assume that it's in a mixture of meters cubed. Okay. So wonder like each of these. So in total, what's our total amount of like the base mixture? Yeah, Sally. So you say 15? Okay. Yeah, that's right. Okay. So 15. That's you in total. Okay, and now underneath, here's what's happening underneath. Okay, either of the two methods that we've discussed so far would work for this particular question. Okay, so I'm saying, okay, underneath, if we need 60 meters cubed in total, right? Question mark, question mark, question mark. Okay, how do I get from 15 to 60? Yes, Merck? Okay, that's what I would say. I'd say if, okay, so we're dealing with the total because I can see the differences in the total here. So if I multiplied by 4 in my like kind of like just base mixture, and then I wanted to scale my base mixture up to the 60 meters cubed, right? I know there's 15 parts in the base mixture, and if I take that base, like that total, and multiply it by 4, I'll arrive at my new total, being 60. Okay? Which means I can take each of the components, because this is like proportional scaling, I can take each of the components that made up that base mixture and multiply them all by 4. Right? So to find the new amount of sand in this 60 meter cubed mixture, we could say, okay, I'm going to take 4 for the sand. Right? We're going to take the original 4, and I'm going to multiply it by the new 4. Or I'm just scaling it by 4. Okay? Which means I'm going to need 16 meters cubed of sand in the new one. Okay? We could also go gravel. I'm going to take the original amount of gravel, which was 6, multiply it by 4. What do we get there? 6 times 4 is? Starts with a 2, ends with a, yes? 24. That's 24. Okay. And the last one being concrete. Okay, we're going to go the 5 times 4. You're going to see 20 meters cubed concrete. Okay? That's not too bad. Looking for that process. Again, if I look back at the first one, I think I'm just having maybe a mental block with the first question. I'm sure it can be done that way. I'm just having a mental block. But we could also represent this question as going, what percentage? Look, if I was looking at sand, I could go 4 divided by 15, the total amount. Get a decimal number, whatever that is. It'd be 0.2667. I could take 0.2667 and multiply it by the new total of 60. Okay, that should also equal 16. Okay, and you could do this process for all 3 of them, and it would work. Whichever one works for you. Okay? Does anybody have any questions? Okay. Now 9, I'm going to let you have a go at 9. It'll be a little interesting. And 10, we're going to spend some more time today doing some more unit rate stuff, so I'm not too worried about that one. And I have a bunch of questions for you to practice. Okay, so by the end of the day today, we should all try and get, or we should all be pretty close to being experts on like unit rates and proportions and then solving these kind of ratio questions, okay? All right.